Hi and welcome to our first video lecture for Chapter 2. There will only be 3 video lectures for our units on ratios, rates, and proportional reasoning, so please stay on top of your homework and videos because this section is going to move fairly quickly. Before we jump into what are ratios here, we already know some things. We already know about equivalent fractions and how to reduce a fraction. So for example, if I give you the fraction of 10 over 15, you would recognize that both of these numbers can be divided by the same number. And in this case, both can be divided by 5, and that would give us an equivalent fraction of 2 over 3, because 2 goes into 10 5 times and 3 goes into 15 5 times. So 10 over 15 here and 2/3, those are equivalent fractions, and we can express 10 over 15 in lowest terms by saying 2 over 3. So today we're going to look at ratios and how they can be reduced to their lowest terms as well. A ratio is simply a comparison of two quantities that have the same units. So we're going to look at 2-term ratios and 3-term ratios. 2-term is just 2 different things that have the same units, and 3-term are 3 different things that have the same units. So what's a 2-term ratio? Let's put a definition on here. A 2-term ratio is a comparison of 2 quantities that have the same units. So we can write this as if we had something that was A dot dot B, or you could say A to B. Oops, A to B. So for example, if we have a bag of marbles here, and this bag of marbles has some blue marbles and it has some red marbles, if we want to talk about the ratio of blue to red marbles, we would say that there are 1, 2, 3, 4, 5, 6 blue marbles, dot dot, so that's how we express a ratio, and then we have 1, 2, 3, 4 red marbles. So I wrote the 6, the blue first, because it says blue to red, and then I wrote the red second. You could reduce that to 3 dot dot 2, because both 6 and 4 can be divided by 2. 6 divided by 2 is 3, 4 divided by 2 is 2. Okay, so what then is a 3-term ratio? Well, that's just a comparison of 3 quantities that have the same units. So in this case, our units are marbles. So this can be written as the first one, dot dot, the second one, dot dot, the third one, or A to B to C. So if we then have a bag of 3 colors, we have blue, red, and brown. In a bag of blue, red, and brown marbles, the ratio of blue to red to brown. So you have to say them in that order. So the first one, blue, 1, 2, 3, 4, 5, 6. So blue first, because that's what it says. Then red, 1, 2, 3, 4. And then brown, 1, 2. Can we reduce this? Yes, we can. 6 divided by 2 is 3. 4 divided by 2 is 2. 2 divided by 2 is 1. All right, so sometimes we're going to have 2-term, sometimes 3-term. Sometimes if you have a ton of colors and you just want to compare 2 of them, we would call that a part-to-part ratio. So it's a comparison of different parts to each other. So different parts of the whole thing to each other in the same group. So we have here another group of marbles. And in this group of colored marbles, if we just want to compare the brown to red, we can count up the brown and say that there are 10 brown and see that there are 8 red. Now don't just believe me, count them yourself. Can we reduce 10 to 8? Yes, we can. 10 divided by 2 is 5. 8 divided by 2 is 4. Can we reduce that any further? No. So our part-to-part ratio of brown marbles to the red marbles is 5 to 4 ratio. So for every 4 red marbles, you've got 5 brown marbles. So what then is a part to whole ratio? Well, we know that whole means the whole thing. So we're comparing one part to the whole group. So in this case, the whole group is the whole bag of marbles, and we would just compare one part. So in this case, we're going to compare the blue marbles. So if we just count up the blue, 1, 2, 3, 4, 5, then there are 5 blue marbles. If you count the whole total, you'll see that there are 23 marbles in total. So the blue marbles to the whole bag of marbles is 5 to 23. You cannot reduce that any further, so that is our final answer. So let's try an example other than marbles. First example, what is the part-to-part ratio of boys to girls in our class? Now, because we're just talking about boys and girls, we could also call this a two-term ratio. So I'm going to tell you that in our class we have 17 boys and 12 girls. So if we want the part-to-part ratio of boys to girls, we need to write the boys first and the girls second. There are 17 boys and there are 12 girls. So you can write it like that with a dot dot, or you can say 17 to 12. And then part B, what's the part to whole ratio of boys to the total? Well, if we want to figure out the total, we can just say, well, there's 17 boys plus 12 girls, means that there are 29 students in our class. That's our total. So the boys is 17 and the total is 29. So we would say 17 to 29 or 17 to 29. Can that be reduced? No, it cannot. Not to whole numbers, at least. We would get decimals if we reduce that. So that's how we do a simple example. Let's try something a little bit more complicated here. We need to read this question carefully because there's a lot of information. Tamara has a recipe for fruit punch that calls for 3 cans of frozen orange juice. So I'm going to skip right down to the table for a second to organize my thoughts as we read this. This row here talks about how many juice cans there are. And we just learned that there are 3 cans of frozen orange juice. So I'm going to write 3 there. 2 cans of raspberry juice and 1 can of lime juice. For each can of concentrate, she must add 3 cans of water. And all the cans are the same size. So she's going to make one recipe of fruit punch. Well, first of all, we can already see that 3 plus 2 plus 1 equals 6 cans of frozen concentrate total. So she needs 3 orange juices, 2 raspberries, and 1 lime. But since they're concentrated, they come like really packed up, like super sugary, so we need to add water to dilute it a little bit. And it says that you add 3 cans of water per every juice. So here, even in this example down here, 3 cans of water per every 1 concentrated can. So if we're going to have 3 cans of orange juice, then we would say 3 cans times 3 cans of water per can means that we need 9 cans of water there. Raspberry juice, well, we have 2 cans of raspberry juice times 3 cans of water is 6 total water cans. And here we have 1 lime concentrate times 3 cans of water per lime gives us 3 cans of water there. So if we say 9 plus 6 plus 3, we're going to get a total of 18 cans of water. Now, if we want to say how many cans are in that punch of all the concentrate, all the water, how many total? Well, we can just say, well, there's 6 concentrate juice cans and there are 18 water cans, so we have a total of 24 cans in this punch. Hope it's a big bowl. So let's now complete these questions now that we've organized our thoughts. What's the ratio? So we're looking at the ratio today. What's the ratio of orange juice to lime juice concentrate? Express this in 2 ways. Okay, so orange juice, we know that we have 3 cans of orange juice here. And lime juice, we have 1 can of lime juice. So that would be one way to express it, 3 to 1. Or you can do it in words, 3, 2, 1. Oh, so I'm going to just clean this up a little bit here. So those are 2 ways to express that. And then the next question, what is the ratio of water to juice concentrate? Well, we have a total of 18 cans of water. 18. And then to juice, we have a total of 6. Can we reduce that? Yes, we can. We can divide both of these by 6. And we get 3 to 1. So for every 1 lime juice, we need 3 cans of water. That makes sense because we already know that. All right, last question here. What's the ratio of raspberry juice concentrate to the total punch? Express your ratio as a fraction, decimal, and a percent. So the first thing, what's the ratio of raspberry juice concentrate? Well, we know that there are 2 cans, and in total punch there are 24. So we would say 2 to 24. Can this get reduced? Yes, it can. Both divided by 2. 24 divided by 2 is 12, so our ratio is 1 to 12. Now we need to express this as a fraction, decimal, and percent. So fraction, decimal, and percent. So as a fraction, you could just say 1 over 12. There you go. So there's our answer as a fraction. As a decimal, we would say 1 divided by 12, and this gives us a decimal of 0.083 repeating. So there's our decimal, 0.0833333. And that as a percent, we would say 0.083 times 100 to give us the percent, gives us 8.3 repeating percent. There you go. Now you know how to express different ratios. Please come to class tomorrow prepared to practice this more.